Welcome to the lair of the Batty Boffin.
Hi there Batty fans, time for another dose of speed, distance and time with the Batty Boffin. Now in earlier videos we've looked at calculating speeds or distances or times depending on what you've got, and we've used our formula triangle down there, speed equals distance over time. Down here remembering we cover up the thing we want and what's left is the formula for it. Now in this video we're going to be talking about something that's very closely related to speed, distance and time. Acceleration. What is acceleration? Well, just as speed talks about how your position changes with time, acceleration talks about how your speed changes with time. Now, just a note here, by the way, I'm using the word speed and we've got S for speed down in here. There is also the term velocity. Now, velocity and speed are not the same thing. Okay, we commonly use the terms fairly interchangeably, but if we're talking science, they are actually different things. Velocity has got a direction associated with it as well. So just as an example, if I am running that way at, 5 miles per hour, and I suddenly stop and start running that way at 5 miles per hour, my speed hasn't changed, it's still 5 miles per hour. However, my velocity has, because velocity incorporates direction. So changing from that way at 5 miles per hour to that way at 5 miles per hour is a change in velocity, though not a change in speed. Now, for the purposes of the stuff we're doing here, we are assuming that you are always going in the same direction. If you're driving a car, it's down a long straight road. So for what we're doing here, actually speed and velocity are the same thing because we're not taking any account of the direction. However, check out some of the other videos in the physics section where we're doing things like force equals mass times acceleration and v equals u plus at and all that kind of thing. And there we will be taking account of direction. So just watch out for that. If you've got no direction, speed and velocity are the same thing. But if you've got a direction involved in there, velocity incorporates the direction and it's a different thing. So sometimes when I talk about speed, I might talk about velocity as well, and for this, they're the same thing. Now, acceleration. Speed equals change in position, change in where you are. The change in position divided by the time it took you to change that position. So if you go from this place to this place, that's 1 metre apart in 1 second, your speed is 1 metre per second. Okay, so it's a change in position over time. Acceleration is equal to the change in your speed or velocity. So it's the change in your speed or the change in your velocity over time. This tells us a little about the units that we use. The units of speed we know are a distance over time type of thing. For example, meters over seconds, meters per second, or miles over hours, miles per hour. Acceleration, on the other hand, has the units of speed divided by time. So that's things like meters per second Oh my goodness! Churchill's baggy underpants, what have we got there? Meters per second. Don't ever write fractions like that, it's horrible. Ugh. We actually normally write that as meters per second, and there's a little 2 there. What that means is meters per second, because that's meters per second, your speed, per second, because it's time, yes? So that's meters per second divided by seconds. So meters per second and another divided by seconds on the bottom. You might think that's a really weird unit, and you would be right, it is a very weird unit. But here's how it works. We call that either meters per second squared, or I prefer to call it meters per second per second. Okay? Meters per second per second. And while that may sound longer, it actually makes sense. Let's think about it. One of the most common accelerations we have is the acceleration due to gravity. If you're doing physics, you should know that as g. And the value of g is about 9.81, but often we call it approximately 10 metres per second squared, metres per second per second. And what that means is that if you step off the top of a skyscraper, don't step off the top of a skyscraper, but if you were to step off the top of a skyscraper, your initial velocity downwards, your initial speed downwards would be nothing. As you instant you step off, you wouldn't actually be falling. Your speed downwards would be 0. Later on, you'd accelerate, your speed would be bigger, and it would get bigger by 10 metres per second each second. So I'm just going to write this on the board here. The velocity, or your speed downwards, would get bigger by 10 metres per second each second. So, at time equals 0, I'm going to put v for velocity there. At time 0, your velocity would be 0, nothing. After 1 second, your speed would be 10 metres per second, because that's what gravity does. It will accelerate you down. By the way, we're assuming no air resistance here, so obviously you're falling in a vacuum. We all have them handily, don't we? After 2 seconds, you'd be travelling downwards at 20 metres per second. After 3 seconds, you'd be travelling downwards at 30 metres per second, and so on. Now, in reality, this wouldn't actually happen because you'd have air resistance and blah, blah, blah like that, but assuming you're falling in free space, your velocity would increase by 10 metres per second every second. So the change in your velocity is 10 metres per second per second. You see how that works? If you say it as metres per second, it actually makes sense. So your velocity changes by 10 metres per second. Yep. So those are the units of acceleration, slightly weird ones. We're going to do some calculations with it now. So I'm going to wipe down the board. You're going to pause for about 2 seconds, and that magic kind of black thing that comes in and comes off, and then poof, I'm back again with a new board. See you in a couple of minutes. So just before we go on to any calculations with acceleration, let's just sort out those units. I've got a whole load of units here, and some of them are acceleration, some are velocity. So if you could get out your pens, get a green and a blue, and just sort out which ones are acceleration and which ones are velocity. See you in a minute with that. Okay, let's sort out. Velocity, we remember, has units of distance per time. So anything with a distance divided by a time. Kilometres per hour. That's a fairly obvious one. What else have we got? Miles per hour. Per means divide, of course. Metres per day. That's kind of, I don't know, speed that glaciers move. What else have we got? Millimetres per year. That's the kind of speed of continental drift. What else have we got? Lovely one down here. Furlongs per fortnight. That's not a very commonly used one, but go Google that. Some people have made up some really fun measurements with furlongs per fortnight. What else have we got? Oh, centimetres per day. That's a beard growth if you've got particularly virulent beard. And one or two other ones as well. This one down here. The seconds with a -1 power. If you remember that, and if you're not sure about negative powers, check out some of the Batty Boffin maths videos where we talk about that. But that is the same thing as centimetres with the seconds on the bottom of the fraction. So that is also a speed. And sometimes you'll see them written instead of, per year, years to the -1. Now, I think that's all the speed ones. So all the other ones are all accelerations, which are units of distance per time squared. So metres per second squared, or metres per second. So, oops, now I need green, don't I? Metres per second, and the same way as writing that here with the negative powers, that is the same unit, metres per second squared. We've also got miles per hour squared, so if you were accelerating in a car at a steady acceleration, you might be accelerating by 3 miles per hour. That's a pretty slow acceleration. It would mean that at the beginning of the hour you were, say, going at 30, and at the end of an hour you'd be going at 33. You would have increased your speed by 3 miles per hour per hour. 3 miles per hour per hour. Same thing down here, kilometres per minute squared. That's a bit of a higher acceleration. And that's all of them. So that's the difference in units between velocity and acceleration. I'll see you in another video, and we'll be talking about doing calculations with accelerations there. So I'll see you next time, Batty fans.
Mwahaha! Mwahaha! Mwahaha!